Hello, everyone. Hey there, Jordan.
Hey, Jordan.
Hope you're all having a good day today, your first day at Dreamforce. Thanks for joining us before you start your first night at Dreamforce. My name is Jeff Kinzer, and this is Robbie Burbeck. Today, we're going to be presenting from on-premise to the app cloud, migrating a legacy web application to Heroku. Before we get started, I have to give you the standard legal disclosure. Please don't make any buying decisions based on the content you see tonight. Please make them based on currently available product. All right, now that that's out of the way, talk a little bit about who we are and what we do. So we're part of IT at Salesforce. We work on the enterprise applications team, and our goal is to remove the difficulty of working with IT, HR, and workplace services for our employees. One of the main applications that we work on currently is called Concierge, and that'll be the focus of our talk tonight. Go ahead and show you a quick demo of what Concierge looks like. All right, so Concierge is a desktop and web application, or a desktop, web, and mobile application. Allows you to do simple keyword search for articles and FAQs that help you get through problems that you might be having in your workday. This might include something like registering for the Salesforce Authenticator or fixing a broken phone. We allow people to take action on the articles, save them for later. We can chat live with an IT support agent. And we also show employees their tickets from multiple orgs that are used internally in Salesforce. You can add comments to your tickets, see who's currently working on your ticket, and mark it as resolved.
All right, thank you very much, Jeff. So who in the audience writes code for a living? And you classify yourself as a developer? Cool. And does everyone in the audience know what Heroku is? Have you ever tried deploying an application up there? So Heroku is a platform as a service. It's similar in a lot of ways to Force.com, except you have more freedom of choice of the implementation languages. So you can deploy applications written in Java or Node.js or PHP or a whole host of different languages onto Heroku. And that's really useful for a bunch of reasons, but primarily when you're dealing with data aggregation from many sources, not having to deal with some of the restrictions of Force.com, like the governor limits, Heroku gives you a kind of a more open platform to build those solutions. So at Salesforce, we have hundreds of different production orgs. We have our data. We aggregate data from many different places. So it makes it. We can't use some of the out-of-the-box Service Cloud features that we'd like to. So the architecture for the Concierge application when we were running on-premise looks something like this. So you can access the app from either your desktop web browser or through Salesforce One, and then the application is hosted from a Node.js application that's running on Heroku. That Node.js application would proxy network requests through to our backend servers, which are running inside our DMZ on virtual machines. And then those backend services would communicate with our different instances of Service Cloud. So we have cases and knowledge spread across three kind of main places at Salesforce. We split them out by org for better data separation. So we can have an org for confidential HR-based information, and another org for IT ticketing, and another org for kind of customer-facing questions. So we crawl the knowledge in each of those different Service Cloud instances, and then we aggregate it into a Google Search appliance, which is also running inside our internal network. So we have this kind of hybrid approach of on-premise technology and cloud technologies. As part of IT's 2020 vision, we are, as much as possible, trying to move to a 100% cloud application hosting. So that means that all of this stuff that's running inside our internal network, we need to figure out what to do with it. So We also have issues with some of those. We used to have issues that we'd run into with those on-premise applications. So does this slide look familiar to anybody that's kind of maintaining a legacy on-premise application? Virtual machine configuration that is different from one machine to the next. You're never entirely sure if it's going to be configured exactly the same in each part of your swim lane. We had a big issue with these deployment scripts that we'd inherited from the team that used to maintain the code. They were written in Ruby. We didn't have Ruby expertise in our team, so if something ever broke, which it sometimes would, we had to basically resort to trying to run it again, and hopefully it would pass the second time. We had long and hard outages when we wanted to deploy the code, because deploying the code was a manual process that, it took coordination. So it'd take about 45 minutes to an hour for us to be able to release a new version of the application. And anytime that we did have to request changes to the environment, it was a case of filing a ticket for our infra team and then waiting for that ticket to be kind of worked by somebody. And this would take weeks or sometimes months in the worst cases for those changes to happen from our lowest environment all the way through to production. So Jeff, not understanding all these issues with the on-premise architecture, why did we not originally build the application on Heroku?
This application was started in development a couple years ago, and while Heroku was available, Heroku Enterprise was not generally available yet. With Heroku Enterprise, we get a lot of new features that increase the security and manageability of our application. So one of them is the isolated, dedicated virtual private cloud instance that you get for each of your applications. The next one is the static outbound IP addresses. Previously, with the common runtime, you get IPs from a pool of IP addresses. So it could be anywhere in a large range of IPs. So if you wanted to lock down your user profile for your API user to just a few IPs, you didn't have any way to do that previously. Also with Heroku Enterprise, we now have the ability to filter inbound IPs based on configuration in the application itself. Also, we now have integration with SSO and the ability to have fine-grained user access controls. The add-ons that are available in Heroku can also be whitelisted in a Heroku Enterprise so that your security department can tightly control what add-ons are available for your application. Without these things, we couldn't really deploy our back-end server to Heroku. Now that Heroku Enterprise is available, ideally we would have just pushed it to Heroku. Fortunately, it wasn't quite that simple. Our application had several years of development being deployed on-premise, and there were a few shortcuts taken here and there. So we needed to figure out how to make our on-premise application ready for the cloud. Luckily, the guys at Heroku are really good at this. They put together a set of principles called 12-factor apps. You can find them at 12factor.net. And they were developed over several years of successes and failures building cloud-friendly applications.
Okay, so we're going to walk you through the 12 factors and how we applied them to our application and why we think that they made the application better for our end users as well as much more enjoyable as a kind of day-to-day development experience for us as the developers. The first factor is code base. So one code base tracked in revision control that is deployed many times. This is probably the most straightforward of the 12 factors. Which even then we still weren't doing quite right before. We used to have one code base and we'd end up with two different production artifacts from that. So we would split out our web services based on their functionality. So we would take one code base and half of it would go into one deployment, half would go to the other deployment, which meant that when we were deploying the application locally, we kind of came up with this compromise where we would bundle it all together and deploy it into the application. Which made development faster, but we would also introduce different bugs into production because we weren't really testing with production-like environment in our local day-to-day lives. The second factor is dependencies. So your application should explicitly declare and isolate any dependencies that it has. So you shouldn't assume the existence of a runtime or an application server on the endpoint that you're deploying your application to. So examples of that are your Java runtime, or your Java web server, or a database that your application relies upon. We used to not do a great job at that. We assumed that on the machine we were deploying to that there would be a Java runtime available to us, and we would deploy the application into a Jetty container. This kind of made it a little bit tricky for us, like when we wanted to go and upgrade the version of Jetty, because it wasn't a declared dependency in the application, it was a known dependency that we assumed would be available in the environments. So then the third factor, which kind of leads on from declaring your dependencies, are having external configuration from the application. So you want to split out any of your code that has things in it like your network credentials, or service URLs, or keys and certificates that you rely upon for communication with different services. Heroku provides a really clean way to do this, so you can set environment variables either through the Heroku CLI, which you can see at the top there, or there's a web interface that you can use to go and update your different environment variables. So now in our application configuration, we rely on those environment variables instead of having different versions of the file for different parts of our swim lane. When a password used to expire for us before, somebody in our operations team would have to basically build a brand new artifact, a deployment artifact, check that into source control, promote it through the swim lane all the way through to the production environment. And if there was any disk-based configuration, they'd have to go and make that change on each of our 12 production servers. So it was like a really long and tedious process for them. It was also fairly error-prone as well.
So it's a good segue into the backing services principle, which asks you to treat your services that you rely upon as if they are attached to your application using URLs in your configuration. Examples of this would be the Salesforce org that you're using in a given environment. So for us, we have a development environment, QA, staging, and production. And we promote our application through those environments as we get closer to a deployment. So for us, we have different Salesforce org instances that we use for each of those. And instead of hard coding that in the code, where it's harder to change, we have that in the configuration. Another example of this would be a database, a cache you're using, or something like Kafka, which went GA, I think, a week ago. So in our on-premise application, this is basically what our virtual machines look like. So I mentioned we had 4 different swim lanes, and in each of those swim lanes, we had 4 different server instances. The servers were set up with Jetty installed and Java installed. They had a set of configuration files placed in the Jetty installation directory, and then we deployed our application as a WAR to the Jetty web apps folder. When the application started up, we had a set of synchronization workers that would go out and fetch knowledge articles from the several orgs that we were connected to. This process took probably 30 to 45 minutes every time the application started. The web services were just reading from the cache, trying for service requests from our client, but they couldn't do so until the cache had been fully populated. This meant that until the cache was full, the application was down. So we had at least 45-minute downtimes for our employees. So what we did is we took the cache and we externalized it, just like this principle suggests. Since it was no longer an in-memory cache, we replaced it with Redis. Redis is a highly available, durable, and distributed messaging, a cache mechanism. It's available through the Heroku add-ons. We're using the Heroku-provided Redis add-on. There's others available. But there's plenty of things that you can add to your application as a service simply by adding it as an add-on. And the configuration for how to communicate with that service is added to your application. The 5th principle is build, release, run. This encourages you to strictly separate your deployment process into 3 phases. The phase where you build your artifacts or bundle your assets, whatever your build framework looks like. And that creates a single bundle of artifacts that you are releasing to your application, which is the second phase, where you take the build artifacts and the configuration for the application, and you put it on the application instance. So for us, this is what happens when we promote from QA to staging. We take our build artifacts that we've already tested in our QA environment, and we promote them to the staging environment, where the configuration is slightly different, pointing to a different set of orgs, and we can then test the exact same artifacts in that environment. So then the run phase is what happens continuously while your application instance is running. We have multiple processes, and these processes get cycled. So every time one of them starts, you're running. So this isn't a great time to be doing things like database migration scripts, schema changes, clearing the cache, things like that. You want to do that at the release phase. That's when your build artifacts get coupled with changes you're making to the services and get installed into an application. The other thing I forgot to mention is when you do this, you get trivial rollback. So you can easily roll back to a previous set of build artifacts and configuration. This is the Heroku review apps and pipelines screen. We're going to talk a little bit about review apps a little bit later. But the important thing I want to point out here is how easy it is to promote staging and production through the different pipelines we have configured in Heroku. So you press the button right there, and it gets promoted to staging. You press the staging promotion button, and it goes to production. It's just that easy. The sixth factor is processes. This principle guides you to separate your application into discrete processes that perform very specific tasks and don't have any state. If you need state in your application, that's what your cache, your org, your database is for. So as you might imagine, trying to get around this by using sticky sessions is kind of a bad idea, because as your web application is getting torn down and brought back up, it's going to be very hard to carry those sessions across your application instances. So on the left, you can see this is what our old application looks like. We've got represented the duplication of these servers for load balancing. As I mentioned, we had a synchronization worker. Since we had 4 application instances, we had 4 different synchronization workers, each populating their own in-memory cache, which is kind of a waste of time. So in the new setup, we now have multiple web services, depending on load, and 1 synchronization worker process. It's all we need to go and get articles from several orgs and synchronize it to our persistent cache that stays around even after application restarts. This dramatically decreases the time it takes for our web service process to start up and be ready, because all it has to do is bind to a port.
Okay, that's a nice segue there. So the 7th factor is port binding. So you're trying to expose your application via the port that it binds to. So exposing your functionality if you have an API server through the port that you bind your application to. So instead of running a script to start Jetty, which then would have your application server inside of it, your application server should kind of start itself and, as an artifact of that, bind to a port. It's a slight tweak in the way that I've been used to deploying applications, but it's a kind of very important piece of the Heroku philosophy. The 8th factor is concurrency. So you want to try and scale your processes, scale out via the process model. Basically, I could think to show that. So Jeff is talking about our web services and then our synchronization workers. Well, we only ever need 1 synchronization worker. We don't need multiple sync workers running in the background to go and populate the data. However, in theory, if we acquired another company or we had a big influx of users, our web processes might need to scale additionally. So Heroku makes it really trivial to add additional web services, so you can scale up your application horizontally, and that's as simple as like using the Heroku CLI and adding additional processes. And then if you need to scale back down again, you can do so. And there's plugins that let this happen on demand, so like they can like track the load on your application and then scale your web services automatically. The ninth factor is disposability. So don't be too attached to any of the instances of your application that are running. They could be shut down at any point, and your application should continue to run, like assuming that you have redundancy of those processes. So they should start up really quickly, and then when they are shut down, they should do so cleanly. So you want to think about things like having a durable queue of work. So if you think about a request that comes in from your client and it lands in your kind of web services layer, instead of processing that work automatically, if the web services layer puts it into this durable queue, and then that's picked up at another point by a worker process that takes the work out of the queue and then does something with it. In theory, what could happen and will happen is that your worker process could be killed by Heroku. So Heroku will recycle all of your dynos once every 24 hours. So you need to be able to deal with your application being shut down. So what should happen when, instead of just dropping that bit of work on the floor when the dyno is shut down, you should send the work back into the durable queue, and then it can be picked up again by another another worker process at some point in the future.
So the 10th factor is dev prod parity. It should be pretty obvious at this point in time that the prior factors lead up to having a dev environment that more closely matches production than we would have if we didn't follow some of these principles. So one thing that can help us achieve this is by using similar backing services. So don't use MySQL on your desktop when you're doing development and then Postgres in production. You also want to use the same versions of software libraries. So if you're using a compiler or some sort of asset bundler, use the same exact version in development that you're using in production in the build phase. Also, the configuration mechanism you use to run your application should be identical in your development environment and your production environment. Containers like Docker can really help with this if you have a complicated stack. We're not at a point where we need that quite yet, but it could make a big difference for people that have complex setups. The 11th factor is logs. This urges you to treat your logs as a stream of events. So rather than outputting to files, you simply output to standard out. This allows you to, rather than having an accumulation of log files, so in our application, we used a file rolling archiving appender, which doesn't really work very well on the cloud because you don't really have any guarantees about disk space or the amount of time that your application is going to be alive. So you can't really depend upon that kind of resource. So instead, you just send it to standard out, and Heroku allows you to attach collection or aggregation tools to your application and send it to something like a tail from the Heroku command line tool, or looking at it in the web UI, you can watch your logs from all of your instances within that application. So the final factor is admin processes. This one asks you to version and run your deployment tasks with your code and in a production environment. So this means rather than creating some one-off deployment script for something like database migration and then running it on your local workstation, you have it in the code so that when your code is deployed to the application, you simply connect to the application, like Heroku lets you get a bash shell in an instance of a virtual machine that matches identically with all of your other production instances, including all the build artifacts and the configuration. And then you run it there. So you don't have any more excuse for having one-off, I developed it on Windows and it ran on Linux sort of errors.
All right, so those are the 12 factors. Our old architecture, if we're being generous, we maybe give ourselves like 2 out of 12 for how well we were implementing those. The new and improved architecture, we still have work to do with the disposability. We haven't implemented a durable queue yet, so if our application is restarted and it's a business critical bit of work, we rely on our end user to resubmit that, which is not ideal by any stretch. Jeff mentioned that Heroku has a new offering called their Kafka implementation. So you can now provision that add-on into a private space, and we're going to start to look at that as our durable queue mechanism. So whenever a request comes in from our client, it'll go directly into our Kafka queue, and then we'll have workers that are listening to that message and deal with it at some point in the future. So I want to talk about like some of the advantages that we see now with this cloud-based architecture. And the changes, it's not just from running on Heroku. Like, to run it on Heroku, we had to improve the application. So, and as part of doing that, we are able to now deploy the application with absolutely zero visible downtime to the user. Our deployment process used to take between 45 minutes and an hour if everything went really well. Our new record is 7 minutes, and it's 7 minutes between pressing the promote to production button and doing the verification in production to make sure that everything's working appropriately. That makes a huge difference to our lives. Like, supporting a release is much less of a chore now. And also to the people that like help us support the application, our operations team. They really enjoy working with the Heroku pipelines paradigm. We're introducing fewer bugs into production because we have much more confidence that our local environment is going to match what we're actually deploying to production. So those errors that we used to run into have slowly started to disappear. So touching back onto adding the durable queue, if we'd want to add that into our on-premise architecture, that would have been a long process because we need to figure out which team is going to create the virtual machine for us. We need to get it networked on our DMZ, and it's not a matter of seconds and minutes for that to all happen. It's days, and it's interfacing with a lot of different humans, a lot of different departments. Provisioning add-ons in Heroku is push a button and then it's provisioned within seconds. It's a really much faster process for us. And then the final, probably the most transformative change that we've been able to make is to take advantage of Heroku review apps now. So there is a concept when you're working in Heroku, if you're using GitHub to deploy your application, when I want to make changes to add a new feature, I create something called a pull request in GitHub. So that pull request contains the set of changes that I want to make to the application. What a review app in Heroku does is take that set of changes plus all of your other application configuration and build a complete application stack. And it has its own distinct URL. It'll provision all the add-ons that you need to be able to run the application. So what's really cool is that before you have completely finished the set of changes that you're working on, you can share it with your stakeholders. So I can take that URL and give it to our QA staff, and they can start to test it. Or I can give it to my product owner, and he can provide initial feedback on whether they like the progress of the feature. And you can also share it with external business stakeholders. So you can start to get like a really quick iterative process when you're building these applications. And the final slide here, I just want to talk about like what the new architecture looks like and like what the steps that we've taken to make it like a really secure design pattern, I guess, like in the cloud. So we have two-factor authentication for the client. So before you can even get a session, you have to have signed in with your username and password, as well as authenticate from a separate device. We make extensive use of IP whitelisting between our front-end servers, our back-end servers. All of our API users are locked down to particular IP addresses, and then only the 4 IP addresses can actually communicate into our DMZ to talk to the Google search appliance. We also use, as an additional layer of security between our backend services and the Go search appliance, we use mutual SSL. So both client and server present each other with a certificate, and it's validated. And then we use a load balancer to make sure that the only particular endpoints on the internal services can be hit. I think that's about it. And final quick plug for our application that's up on the App Exchange. If you're looking for an org chart for your contacts or for your users inside of Salesforce One, head over to this link and you can install our org chart application. It runs on Heroku as well, but you can expose it through Salesforce One via Canvas, so it just looks like a native Salesforce One application. We think it's pretty cool. Thank you all very much. Do we have any questions today? Everyone ready to head out? It's getting kind of late. All right. Thank you all.